So the second question gives me a piecewise function, and it asks me if the f is continuous at x equals 0. Now when I go to my formula sheet and I screenshot what I see about continuity, I see that I have to prove a few things in order to say that it is continuous. I need to prove that the left-hand right limit approach the same value, and also that that value does exist and is equal to both of those things. So let's first set this up for both that left and right hand. I know that for all x values less than 0, we're using this top equation, and greater than 0, we're using this bottom. So I'm going to say the limit as x approaches 0 from the left of f of x equals three x squared. We're using that equation, and when I substitute in 0, I get 0. Now from the right-hand side, I'm using that second equation, or second expression. And I'm going to say e to the 2x plus 2. And when I plug in 0, remember e to any kind of 0 power is 1, and 1 plus 2 is 3. Now I notice that 0 and 3 are not equivalent, so I can say a few things here. I'm going to say that the limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right. Therefore, the limit as x approaches 0 of f of x does not exist, and f is not continuous at x equals 0, because we have some sort of jump discontinuity there. Now remember that the AP test is going to grade down to wherever they see a box, so make sure you have some sort of organization in your work. So we're proving that the limit of the left-hand side and the right-hand side are not equal. Therefore, there is some sort of discontinuity, and that doesn't exist. Let's check and see how this compares to the scoring guide. When I check the scoring guide, it says that I get 2 points for considering one-sided limits, or 1 point for considering one-side limits, and then 1 point for the justification, 2 points in total. So 1 point for considering each sided limit, so I have right here, and then my justification would be all this business right here, where I'm saying that the left-hand, right-hand limits don't match. Therefore, the limit of f of x as x approaches 0 does not exist, and it's not continuous at that point. Now remember, we have to include, just stamping right here, we have to include the word continuous because our question asks, is it continuous at that point? Our second part, or part B, says to evaluate f prime of 2 and f prime of 3. So I'm going to be looking and seeing which part of my function is that actually going to fall into. So for -2, or that first value, I'm going to be using this first function because that's all my values less than 0. And then for this f of 3, I'm going to be using the second function here. Now it does ask me, -2, it does ask me to find that f prime. So I'm going to say right here, f prime of -2 equals, and I need to use that side of my equation. Because it asks for the derivative, I'm going to derivate this 3x squared plus 2x. 3x squared plus 2x. When I take the derivative, I should get 6x plus 2. And remember, I'm evaluating at x equals -2. So I'm going to say that line evaluating at x equals -2. And when I do that, 6 times -2 is -12, plus 2 is -10. So f prime of -2 equals -10. For f of 3, we're using our f prime of 3. We're using that second equation. So let's derivate e to the 2x plus 2. Remember that that just becomes 2e to the 2x. That 2 goes away. And I'm evaluating that at x equals 3. When I plug that in, I just get 2e to the 6th. So I can come down here and say f prime of 3 equals 2e to the 6th. Let's do a quick check and see how we did compared to the key. Our key right here says that we get 2 points for this guy. We get 1 point for getting the correct answer for f prime of 2 and another point for getting the correct answer for f prime of 3. We are good to go. Part C asks us to explain why f prime of 0 does not exist. So in part A, we proved that it was not continuous at f prime of 0, or f of 0, my apologies. So why f prime of 0 does not exist. Now f prime is noting the differentiability, and remember, for something to be differentiable, it must be continuous. Ooh, writing in highlighter still. So for something to be differentiable, it must be continuous. So for f prime of 0, does not exist because it is not continuous at x equals 0. And I actually messed up here. I'm going to make one quick modification before I finish. And I want for you to take a second to look at that and see what did I do that I should have probably not have done. Hopefully you thought about this guy right here, this word it. Remember that we need to be naming. I can't say it's not continuous because, like, what does that mean? Make sure that you are naming f is not continuous at x equals 0. And then I could also say see proof in A. The answer key to this one just gave us 1 point, and it was just for the explanation. So we are already good to go here. Last but not least, let g be the function given by g sub x equals the integral from -1 to x of ft dt. Find g of 1. So first off, I'm going to rewrite by plugging in. I'm going to say g of 1 equals the integral from -1 to 1 f of t dt. So when I look at which piece of this function I'm going to use, I know that there is a break at 0. So I'm actually going to be using both of these pieces of this function of f. So I'm going to rewrite this integral as a combination of two separate integrals. So I'm going to say that this is going to be the integral from -1 to 0 of 3t squared plus 2t dt. Make sure you're plugging in t for that value, plus the integral from 0 to 1, because there's that break and we're using that greater than 0 function here, e2t plus 2 dt. When I plug that in, I need to integrate, well, let's integrate first. So let's say that this is going to be, this t squared becomes t cubed, 1/3 times 3 is just t cubed, plus you have t squared divided by 2, so 2 divided by 2 is 1. And that's being evaluated from 0 to 1, or -1 to 0. And then that second piece, when I integrate this guy, I get e to the 2t divided by 2, or 1/2 e to the 2t, plus 2t. And we're evaluating that from 0 to 1. Getting all of that plugged in here, we have 0 plus 0, that -1 gets plugged in, so we have 0 minus -1 cubed is -1, -1 squared is 1, plus that whole first piece. Plugging in 1, we should just get e squared divided by 2 plus 2 minus e to the 0, which is 1, so 1/2 plus 0. And remember, we can just leave it like this. If you did take it down all the way, you would get e squared over 2 plus 3/2. Let's take a look at what our answer key said and check up against that. So here we go right here. We got 1 point for our integrals. Note that that's integrals plural, so that means that you knew that you were breaking that up because of the piecewise function. We got 2 points for our antiderivatives, so that means that we evaluate each of these guys correctly. So there's 1 point for that first one, 1 point for that second one, and then we got 1 point for our answer. So remember, you could have just left it in this form, the fully expanded form, or you could have left it e squared over 2 plus 3/2. And there's all 4 points, folks.